Now coming to the formation of the micelles or aggregation particles. We have already discussed that these micelles are formed by the aggregation of dispersed phase particles. These are formed by aggregation of particles. Take a simple example, soap solution. This soap contains a chemical component sodium stearate, which has a chemical formula CH3CH2 16 times of COONA. It is a salt of the corresponding acids. That means it has a long chain hydrocarbon, and at the end it has some polar groups, that is, which are present as a acid. So from this you can easily say this all is a non-polar hydrocarbon chain. It is a polar group. So when you dissolve this soap into the water, then what happens? Aggregation of this sodium stearate is occurred. See here, when this aggregation is occurred, suppose all are particles in the water. In this, all are the sodium stearate molecules. So this round will indicate the polar group. This is the polar group, and the corresponding tail is called non-polar group. This is the head, which contains the polar group, and it is tail, which contains the hydrocarbon chain. So this hydrocarbon chain does not dissolve in water, but this polar group, which contains the acidic group, is dissolved in water. That leads to formation of the aggregation of the particles as shown in this picture. Here what happens? All comes to close, and the polar heads are faced to the solvent, because here the water having polar in nature, so they have a good interactions with the polar, that is head of the molecule or sodium stearate. It has a good interactions, or it can forms the hydrogen bonds with the acetate ion. But this hydrocarbon chain has a non-polar in nature, and they comes close together with the non-polar tails, and they forms a aggregation like this, and this is called micelle. In each micelle there is around 70 to 100 molecules are possible, and the limit of concentration, that is 10 power minus 4 to minus 3. If we access this concentration of the soap into the solution, the formation of micelle will occur. That's why the CMC, critical micellar concentration, is very important for the formation of the micelles. The above region only the formation of micelles will occur. If in the dilute solution, they simply act as a normal electrolytes only, because it presents a positive and negative ions. But above that region, they are aggregated as shown in this picture, and they forms a micelles. This is called critical micellation concentration, CMC, and the corresponding temperature is called Kraft temperature. Now you can see this formation of micelles in this picture, and these are the long chain sodium stearate particles, and it is a polar group which is called as head, and it is a non-polar hydrocarbon chain, it is called as tail. And when these are divided from the soap, when you immerse it into the solution, when you are washing the clothes, they are forms a layer type on the water, because these are the polar heads. They are forms a corresponding hydrogen bonds with the water, so they are othered with the heads only. And after this concentration is very high, which is more than the critical micellar concentration, then what happens? These are aggregated to each other in the form of like a round ring, and it forms the corresponding micelle. As shown in this picture, they form the corresponding micelles. And these all are the heads groups which are faced to the polar solvent, and tail groups are immersed into the ring, which is not soluble in the solvent. And these micelles are responsible for the cleaning action of the soap. That is, these formation of micelle are responsible for cleaning action of soap. And example here is sodium stearate, which are present in the soap or detergent. And some other examples are cetyl trimethyl ammonium bromide. This is also a salt of ammonia, which has a molecular formula CH3CH2 15 times CH3, ammonium bromide. In this case also, this act as a polar head and this act as a non-polar tail, hydrocarbon chains. And another example for this type of substances is sodium lauryl sulfate, which has a molecular formula CH3CH2 11 times, and here head group is sulfate ion. This is polar group and this is non-polar. So in this case it acts as a tail and it acts as a head. This is the formation of the micelles.